Good afternoon, everybody. Today we're watching this weather event that's happening up in the Dakotas, parts of Minnesota. And we're watching the tropical storm make landfall. Throughout the day, there's been several tornado warnings with this storm. Also, there's also a few tornado warnings up in the Dakotas, north of Ashley and North Dakota, and west of Arbutin. So we're going to quickly break down the weather analysis and see what is happening. First, we're going to go on the storm prediction page, see what has been happening. So as we can see, they updated this 6 minutes ago. They're going to keep the enhanced risk with a 10% hatch area over here in northwest Minnesota. As we can see, the 5% runs down through North Dakota and South Dakota. As we can see, there's a 5% risk all the way down in here. Parts of Louisiana, Mississippi, parts of Mobile, and Gulf Shores, and all that. As we can see, they had a mesoscale discussion. A few weak transition circulations had been observed. Brief weak tornado with strong wind gusts cannot be ruled out. As anytime you have a tropical storm of some sort making landfall, you can always get that happen. So let's break down the environment that these storms are in currently. And let's look at the current fronts, see what is happening. So as we can see, the latest, we have a big low up in Canada. And we have a trailing cold front, and we have a warm front, and we have another. Um, this map is indicating a low over South Dakota of some sort, but as we can see, um, these storms are in the warm sector. Looks like there's temperatures up in 88 with dew points in 70, but we will further look at this um, analysis on the meso-analysis. So we're going to look at the northern sector. As we can see, these line of storms and where they are at. So first thing first, let's look at the temperature, wind, dew points. As we can see, we got surface temperature, dew points. How we can tell what each is. The red represents temperature, and the little shaded areas represent dew points. As we can see, it looks like it's about 88, 72, 74 through this region, with dew points being in the 60s by the looks of it, with 70s in some parts in here. So our warm front's about right in here somewhere. But we can probably see that with our helicity values. We'll look at our SR helicity, so you can see our warm front's about right through here in this region right here, and our cold front's back here. As we can see, there's plenty of effective helicity through this region. About 200 to this about 200 through this region, maybe even up to 300. See, that's 100, 200, and 300 in a few spots. So there's enough helicity in the atmosphere um, for these steam to feed on. We're going to look at the new SR helicity. This is taken from surface all the way up to 500 meters, not 1,000 or kilometers. So this is the um, between the surface and the 1 kilometer. This is a new thing that the Vortex 2 has come out with. This can indicate probably where the best tornado chances are, because there's the best amount of spin through that area. As we can see, there's about 100 through this region right in here. And I think if we look back on our uh, tornado warnings, those are where exactly those tornado warnings are occurring. Is where that SRH 0 through 500 meters are occurring. As we can see, that is so. Um, I've been see right through here, and as we look back about 100 through here, that's exactly where that tornado warning has occurred. So here's a new formula they came out with a significant tornado using the 0 to 500 meter SRH. As we can see, that where that tornado warning is occurring, it has a 3 over this region. But as we can see, it looks like there is some uh, convective inhibition or CIN, but with the winds being stronger to the 500 meters, there could be a chance of a tornado being down. As we can see, the supercell composite's only not the greatest, but this is using a different formula to predict this. This is using most unstable Cape, the SRH, the differential winds, and using convective inhibition. But as we look at Cape surface base, as we can see, about 2,000 joules, 3,000, um, 3,000 joules, but there is some convective inhibition, but I don't think it's that strong. As we look at the surface, 0 to 100. As we can see, where the 0 to 500 meter SRH is the strongest is where the tornado warning is occurring. Nowhere else right now, which is kind of interesting. We're going to look at our LCL heights. So we can see where the storm is occurring, the LCL heights are about 750. And if we look at LSC, they're moderate. They're pretty close together, relatively speaking. But definitely plenty of bulk shear effective through this region. We can probably look at the surface 1 kilometer bulk shear. Definitely plenty of surface of 0 to 1 kilometer shear. 0.3. Definitely through where that tornado warning is occurring right now. Surface 8. So as we look at the lower winds, so we can see that the lower winds are stronger through this region. The surface winds. As we look in the upper atmosphere, there's plenty of upper winds with this system, which will definitely help these storms develop and help initialize new thunderstorm development and quite possibly help break through that convective inhibition through that area. As we look at the energy helicity, as we can see, I think there's plenty of energy helicity index. This takes in consideration both Cape and SRH from 0 to 1 kilometer. We look at 3 kilometers. So definitely these storms are probably breaking. They can quite possibly break through that convective inhibition, and a tornado could happen. No doubt in my mind. I haven't really looked at the velocity, what the velocity looks with the storm. Let's see what's happening. Okay, so the tornado warning just took out, but it looked like it did have tight couplet for a little bit, so maybe a chance of a brief tornado did occur. It looks like the storm became linear, looking like it's more of a wind event now. Let's see if I can take the warnings off. So there could have been a brief touchdown tornado, but not sure. Now we'll go to the next lab into its radar. Oops. Let's look. Hmm. Hmm. That looks kind of funky. Okay. So that definitely did not go in our favor at all. Let's see. So it was definitely this system right here. As you can see, right in there was where the couplet was, if I can get it to pause. So the couplet was about in this region right here. But as we can see, it looks linear now. See, this greatest tornado threat will persist through the mid-evening from eastern um, North Dakota into northwest Minnesota, after where the 0-1 photograph size is maximized in association with a strengthening low-level jet and back-end surface winds near the warm front. So where that warm front was, we saw there was great amount of helicity up here, where warm fronts running right through here. And we can see with our energy helicity index is the greatest through this area. So these storms up here definitely have a chance of becoming tornado producers. If we look at the critical angle, uh, well, see if they actually are tornado warned, or if they're all severe thunderstorm. Looks like possible rotation. So we see we had two tornado warnings earlier. Now let's look down here where our tropical storm is currently at. As we can see, normally I like using surface-based cape. So our surface-based cape is strongest through this region. Right here. If we look at effective SRH, we can see our SRH is greatest through this region too. So yes, definitely a chance of a brief spin up tornado could happen. See our 0 to 500 is greatest through this region too. And our energy helicity index is a 2 through this region. are supercell composites greatest to this region. So yes, there's definitely is a chance of these storms producing a quick, brief spin-up tornado through this region right here. Is there any tornado warnings with it right now? Let's check it out. No current warnings as of right now. Check Mobile. Nope. Might need to watch the storm up here. SVC Supercell Composite is a 12, and I think that's where, when we looked at mixed layer Cape, this is the only area where there's not as much convective inhibition. Let's look at SRH. It's near 200. About 100, not the strongest. About 100. So this storm up here has a chance, maybe. It can do it. Yep, that storm. See if there's any rotation with it. Nothing with it so far. So, we'll have to see. I mean, EF2 is 11 to that area. So nothing above an EF2, so. Well, let's see. Usually, see what the HRRR or the NAM shows what the what's gonna happen in the next couple of hours. Or the wrap. That'll work. Okay. None. Okay. think that this shows the storms are up here. Wait, tornado. Um, yeah, you can definitely see there's like some sort of capping, or we see it's not surface based, so it's not getting effective inflow from the surface. So it looks like it has them weakening or becoming more linear. It looks like some sort of like bow echo might form later. See what it does with the supercell composite. It weakens dramatically. Probably going to suspect these storms to weaken fairly quickly. Um, we can even see the mixed layer cape going down to the evening hours. So, wow. The violet tornado parameter of a 7 back in here. Which is exactly where that there's very little convective inhibition right now. Seems as though if there's going to be another tornado warning, it would be in this area right here where there's a pocket of no convective inhibition. You can see a little cell forming, but it looks like it's because of this outflow boundary that came from this storm. You can see this little form. So it'd be interesting to see if there's going to be anything going to form within within that area. So it looks like that storm might be gaining strength. I mean, it exploded really quickly. Right there, boom. That storm might be something to watch right now. I mean, it's in a very favorable environment. I mean, it's got plenty of bulk shear, even at the surface. Well, it's relatively weaker from 0 to 1, but it's still getting about 15 knots. But if we look at our SR velocity amount of spin, it's got about 100. So there's definitely plenty of spin in the lower levels of the atmosphere. Surface 1 kilometer, about 100. If we use the new SRH, I mean, it's a 4. So it's definitely saying, hey, something might happen here. And if we look at our fixed layer, effective layer, we can see about a 4 of 3 through that region. I think our energy helicity index is about a 3, small dot of a 3, so there's plenty of energy within this region. And that's because, as we can see, if we look at mixed layer CAPE, there's about 3,000 joules per kilogram of CAPE with no convective inhibition. This storm has no convective inhibition within this region. So, definitely a storm to watch. If we look at 0.3, so it's not too strong, but it's still there. And I see our 0 to 1 kilometer is about 3, but I think as much energy is through that area right now, something could happen. Violent tornado parameter, I mean, it's a 6 right there. In case y'all don't know, violent tornado parameter uses mixed layer CAPE, LCL heights, storm relative velocity, deterring within the atmosphere, UBWD, or effective bulk wind difference, and lapse rates. And that's how it comes up with this number, so it takes in consideration of all that. So considering that's there, that means our LCL heights must be low. And as we can see, our LCL heights is low right there. LCL heights are super low right there, so that's very, so definitely with high dew points and all that, it could help bring those clouds down. Look, our LOC heights are pretty close to the LCL heights. So these storms over here, the storm that's firing up within this region definitely need to be watched. Refresh it. I mean, you can see exploding. It just exploded because there was an outflow boundary that just went through this region because of these storms down here, and it just exploded. So my eyes are on this region right in here as of right now. As we can see, our effective velocity went up to 200 through this region. So this storm through this region definitely needs to be kept eye on. As we can see, that storm up here in Minnesota, what I said, actually did went tornado warn. Well, it doesn't show on there, but on their maps, it shows a tornado warn. So these storms up here, I was just talking about, uh, just went tornado warn. So, as long as you have some high energy helicity through that energy area, which there is. So I think it is definitely able to break through that cap or that convective inhibition that's in that area. And it's right along that warm front. So, yep, my eyes are definitely on this storm. And the other storm I was talking about earlier actually did go tornado warn. See. Man, this website is so behind on. Okay. You can see that broad rotation right in there. Right there, yep. On one next lab. Radar is acting up. See if it's not acting up anymore. I use as far as it would be this storm. So right there you can see the rotation clearly. With that storm right there. So it's about right in there. So actually this one. Yeah. So it'd be that storm. I think. Yeah. So it's this storm that's tornado warned right now. You can definitely see the rotation right there. Let's refresh and see what's happening with this storm over here. It looks like it's still growing. means directly over that storm. The significant tornado parameter over this storm right here. So this storm definitely needs to be watched. Another tornado warning. There's another tornado warning. It's for this system right here. So it's on the edge of South Dakota. So let's see if we can do this. Let's go velocity. Oh yeah, you can see the couplet right there. Awesome. So plenty of 0 to 1 kilometers. I'm going to surface to 500 meters, so plenty of that. So it's that storm. So it's in the 1. It's probably because of the convective inhibition in that area. So like I surface 1 kilometers. But there's plenty of energy helicity through that area. Interesting. In the fixed layer, it says 2. If we look at the effective area, it says no. So, in case anybody was wondering what fixed layer is. So, it says when the surface-based convective inhibition term is set to 1.0 when surface convective inhibition is greater than negative 50. And it's set to 0 when surface-based convective inhibition is less than negative 200. Which in this case, I think it's set to 1. Oh, it might be set to 0. Because there's looks like this darker blue is over 100. So you can see the couplet on that one. And you can see a broad rotate couple it on the other one. Now, as for this storm I'm watching, it's trying, I guess. We'll just have to keep watching it. Who knows? It might not do anything. Be kind of interesting because I mean, it's in the most favorable spot ever for anything to happen. Not a lot of energy helicity, but it's still over 2. But surface 3 is to 3 kilometer looks really good, so maybe. Gotta keep our eyes on it. Hmm. Supercell composites is 16 to that region, so it's really high. Mhm. Alright, so here we go. A new method scale discussion. One about discrete cells, and the other one being cell clusters. Severe threat remains across much of this watcher. Storm mode is beginning to change. Okay. Discrete supercells have been tracked cycle north eastward near the Minnesota North Dakota border over the last few hours, while storms have exhibited mid-level rotation, but only one or two storms have demonstrated low-level radar signatures. Indication a potential tornadic circulation included one current in Marshall, Kinston County. A tornado threat remains is likely highest in far northeast North Dakota and northwest Minnesota. Okay. Storms in the southern western portion of the watch are beginning to cluster and may form a QLCS in the next few hours. These storms have history of large hail, damaging winds, and a tornado was also reported. All severe threat remains possible, although severe winds may become the main threat if a QLCS transition occurs. Storms may linger in the watch past 03Z, and a watch extension or a new watch may be necessary. Okay. As we see, there's very little 0 to 500 meters of SRH to that region. So it's probably another reason why they are having a hard time reaching all the way down to the surface. how is my storm doing over here? We will find out. Oh no. Doesn't look too good. Not very promising anyways. So what's happening? Why is it not doing anything? As we can see, it looks like the environment has changed. There is not as much 0 to 500 meters SRH. Why did this happen? I have no idea. I bet you it's probably because of all the impedance happening from these storms. Maybe. As we see, a lot of the helicities along that warm front. Berkshire has definitely shifted more. Maybe not. Well, oh well. It happens. Wow. Well, violent tornado parameter though, right? It's a 10. Well, sometimes the violent tornado parameter just depends on the storm mode, and as we can see, the storm mode is becoming more clustered. Oh, very interesting, to say the most. Sometimes it's just not meant to be. It looks like they took off the tornado warning. They did. Well, alright, folks. Um, Looks like for the rest of the evening, these storms are becoming more, will start becoming more cellular. I meant more clustered. Even the SPC guys are showing that. I even showed that on the 8 Triple R how it looks like everything's gonna start becoming more linear. So maybe more of a wind event. HRH is mainly along that warm front that's in Minnesota. Um, so tornado threat still not 0, but it's there. It's not the greatest chance. The there's some convective inhibition these storms are gonna have to work through. And as we look at the 0 to 500 velocity, it's still relatively strong through this area, so there's still a chance of maybe a brief spin up tornado. If we look at our 0 to 1 kilometer AHI, there's pockets of them. So definitely, if a storm is over one of those pockets, the chances are still there for a brief spin up tornado to happen. But overall, it looks like the system's gonna become linear. So until then, I'm gonna end my stream here. Hope everyone has a good day. And real quick, we'll look at if any more weather events gonna happen this week. I try to get on here when I can, but um, life is getting really busy. As we can see, there's a marginal risk over my area. Oh, I'm in the 2% chance range tomorrow for tornadoes. So looks like I'm gonna have to watch my region down here in Alabama with a 5% across Mississippi because of the tropical storm coming up through this region. So I'm in the 2% chance range. Let's see. Based on the latest model outputs, it appears that potential could be maximized in the 18 to 21 time frame across eastern Mississippi and adjacent western Alabama. And where southerly's 850 millibar flow may remain as strong as 40 to 50 knots as the boundary layers of circulation begins to peak. So I would definitely have to watch my area. I'm definitely in the 2% chance risk. Um, it'll be interesting for sure. I was actually looking at this earlier. Noticed I might have a slight chance. Um, but it'll definitely be interesting. As you can see, we'll look at my current storm. It just completely died. Oh well, it happens. It exploded and it just weakened. That's that's interesting. Oops. Hmm. Well, all right. Well, I hope everyone has a good day. Um, I'm in the 2% chance tomorrow, so I might or might not come live. Tomorrow's gonna be a busy day, first day of college for me. Yay. Anyways, so then I hope everyone has a good day and keep your eyes on the sky.